Table going. What we start with? We start with the
chart.
Yes. And what do we start with in the chart?
The infinity.
Exactly, the domain, of course. Perfect. Perfect. So we get the chart going and everything. When we find out something, we discover something, we put it in the table. Okay. The first thing we have to discuss is, let's say, domain, which we already did. Second important step would be degree. Very good. Awesome. Well done. Degree 5. Good. Maximum possible number of turns.
4.
Max 4. Awesome. Good. So let's find the X-intercepts and the multiplicities. How do I do that?
0.
Which one? Yes.
Y.
Excellent. Thank you very much. So we have x squared, x minus 1 cubed equals 0. How many solutions will you come up with? Exactly. The degree. Perfect. Perfect. Okay, I'm waiting for 5 solutions.
4 zeros.
No, 3 ones.
Very good.
2.
And 2 zeros. Awesome. So what is the multiplicity of x equals 1? Perfect. What is the multiplicity of 0? Good. So I put in the table 0 and 1. What do I write above 1? Above 0? What do I write above 0? To remind me to do that the function does what there?
Turns.
Very good. Awesome. Okay, what will I say above 1? Which time? Very good. Awesome. Very good. Well done. Good. There is no point in finding the y-intercept because when I plug in 0, I get 0. That's also the y-intercept. Now I have to identify the end behavior. So now let's think right here. This is what we have to determine, and we're done. This is it. So since the degree is 5, which means even, the end behavior will be similar to the end behavior of which function? Linear. Linear. It's either this, if the leading coefficient is positive, or this, if the leading coefficient is negative. Which one is it? Yes, so it's this. Perfect. So from negative infinity to infinity. I know the function cannot be symmetric. If it turns at 0 and it crosses slowly at 1, it cannot be symmetric. But I would have to write that f of negative x does not equal f of x, and f of negative x does not equal negative f of x to show that I know what symmetry means. Not even and not odd. This is it. So now let's try to make sense of this information before we graph it. So please follow me for a second. The function is coming from negative infinity, increasing to the origin, but it turns at the origin. So it has to come to a minimum because it comes back and crossing at 1, 0 very slowly, going towards infinity. One more time. From negative infinity, it's coming up to the origin where it's turning. It has to come down to a minimum value because it comes back and crosses at 1 very slowly, going towards infinity. That's the graph. So, ready? Let's plot those two, 0, 0, and 1, 0. It's coming from negative infinity to the origin where it turns. That's what you told me, and that's perfect. It has to have a minimum here, no question about it, because it turns again. It has to turn and comes to 1, but look what happens here. slowly, slowly. It's not a cross like this. Please do not graph it like this. This will be a solution with multiplicity 1. But multiplicity 3, it looks like this. So this is our function, f of x equals x squared, x minus 1 cubed. Yes, we can graph it with the graphing calculator because we have to determine the max min. Let me know when you're ready. Ready? Okay. So these functions look difficult, but if you follow through, if you determine everything you need in the table, you fill up the table, you'll have no difficulties. So this was x squared and x minus 1 to the third power. So I want to use what kind of viewing window? Not the standard. I really don't. Why? Because I already have the graph. So I'll go to -5 and 5, and not too low because I don't think that's a huge minimum, and not too high. So I'm going to say -5, 5, -3, 5. So -5 on the left is too far out in anyway, but that's good. -5, 5, -3 to 5 with a scale of 1. So graph. It's coming from -infinity. We'll turn at the origin. False, right? It's not possible. It cannot be flat for the x-axis. That's not possible. There must be a minimum here. And it turns. Look how slowly it crosses. So I have to zoom in to show that. So I will change the y-axis into -1. Oh, that's not what I meant. Where am I? Is it frozen? Oh no.
Just close it out.
Yeah. Sometimes it doesn't work. Even if I do this, let's see. Okay. So we had x squared and x minus 1 to the third power. Okay, so the viewing window we said -1, okay, to 2, yeah. And y min, no, that's not what I wanted. I wanted -1 is fine, 2 is fine, yeah, that's okay. Y minimum, -1 to 3. It's coming. It's still not good enough. It turns. It comes to a minimum. It's not very clear, so I have to go to maybe the negative side should be -0.5. Yep. -0.3. It's very clear there is a minimum here, right? And look how slowly this is crossing here. Very slowly, because there are 3 solutions, x equals 1. So I'll find the minimum between 0 and 1. So second in calc, I want a minimum, which is number 4, between 0 to the left and 1 to the right. Just give me the minimum. I don't want to guess. And the minimum cannot be that. I clicked on maximum, that's why. Okay, so minimum is 3. Sorry about that. So between 0 and 1. And I don't want to guess, just give me the minimum. So the minimum is 0.4 roughly. At x equals 0.4, -0.03. So I put it in my table. At 0.4 approximately -0.03. So this is the local min. So be careful, do not rely on the graphing calculator. Do not grab the calculator before you present all this information because you see, The calculator sometimes is lying to us. Very good. Is there anything else we would like to go back to? Anything else? Okay, so the target of today is to refresh our memory on 3.3. This was done in the previous course, but I consider it that I have to present it. I think I have to present this and refresh your memory. So this is 3.3, a division of polynomials. Just real quick, and then we'll start 3.5. Okay, so let's suppose I have 3x cubed minus 2x plus 1 divided by x squared. This is a division of a polynomial divided by one term, which is a monomial. Basically, in this situation, there is not a real division. The only thing I can do is separate into 3 fractions, y3, because the numerator has 3 terms. So 3x cubed divided by x squared minus 2x divided by x squared plus 1 over x squared. All I can do next is just simplify a little bit each fraction. I remove 2 x's from the bottom with 2 x's from the top, so I get 3x. I remove an x from the top with an x from the bottom, and I get negative 2 over x. And then I just copy 1 over x squared. So if you would say this is not a real division, I would have to agree. That's the only thing we can do when the denominator is one term. Now, when the denominator is 2 or more terms, let's say a polynomial over another polynomial, we have 2 options. So by q of x, I mean not one term, but 2 or more terms. So if I have to divide 2 polynomials, and the denominator has at least 2 terms, I have what is called a long division. And also, that works in all cases. And I also have a second option, but that has limited applicability. It doesn't work in all cases. For example, a polynomial at the top can be anything, but the denominator is x minus a number. Linear, this is a linear polynomial. And a can be anything, positive or negative. In this situation, we can use the long division, but we can also use a different method called synthetic division. So let me refresh your memory on the long division first. And I'm going to pick a problem from your book. And you can choose. Feel free to choose if you want to. Let's start with, let's say, 13 on page 392. And that is 6x cubed plus 13x squared minus 11x and minus 15. Everything divided by 3x squared minus x and minus 3. The first question I ask myself is, are these 2 polynomials in descending order? Yes, they are. The second question I ask myself is, can I use the synthetic division? Let's compare this to this, and then we know the answer. Is this a linear polynomial? No. So I cannot use the synthetic division. Is that clear?
Mm-hmm.
Okay. So the only chance I have to divide these 2 polynomials is by using the long division. Last question I have is this. Is there a missing term at the top? And you can say, wait a minute, how do I know that? Here's how we know. What is the degree of this polynomial? 3. So is the term with degree 3 there? Yes. Is the term with degree 2 there? Yes. Is the term with degree 1 there? Is there a term with degree, not power, degree 0 there? Yes. So there is no missing term. What happens if there is a missing term? Do I have to leave some room when I perform the algorithm?
What would be a missing term? Like if 1 was missing and it just went from 2 to 0?
So degree 3 is there, degree 2 is there, degree 1 is not there, degree 0 is there.
Okay.
Any of the terms? So any polynomial, any degree, degree 15 should have 16 terms. If it does not have one term, then one term is missing. Better?
Mhm.
So now let's start the algorithm. It's exactly like a long division, a numerical division, the same procedure.
Oh my God.
6x cubed plus 13x squared minus 11x minus 15, and we are dividing by 3x squared minus x minus 3.
This is about to be childish.
So then we know it and we can move on. Do I still have to show it?
Yeah, absolutely.
Good. I love being a kid myself, so that's good. Okay, 3x squared. 3x squared multiplied by what is 6x cubed? Very good. Perfect. We distribute 2x to these three terms. We change the sign because we have to subtract and write below specific like terms. Ready? 2x times 3x squared is? But I have to change the sign because I subtract. No. At the top, we don't lie. When we distribute, we lie.
When 2x times 3x squared is
If I put negative 2x, is this 6x cubed? No. At the top, we do not lie. Good. So 2x times 3x squared is 6x cubed. Change the sign. 2x times negative x is negative 2x squared. We have to lie. This is the only time we are allowed to. 2x times negative 3 is negative 6x. Perform the operations you see. 13x squared plus 2x squared is 15x squared. Negative 11x plus 6x is negative 5x. Bring down the next in line. Final question. 3x squared times what is 15x squared? At the top, we don't lie. I need the sign.
Plus.
Very good. Awesome. So let's distribute. Now when we distribute, we lie. 5 times 3x squared.
15x squared.
5 times negative x.
Plus 5.
Negative 5x, so plus 5x. And 5 times negative 3. Negative 15, so it's 15. Nothing. What is the remainder? 0. How do I write the answer? Quotient 2x plus 5. I should not write this. I just want to remind you how to write it. Plus 0 divided by 3x squared minus x minus 3. And there is no need for this. But if the division had a remainder, we would have put it at the top over the divisor. Quotient, remainder, and divisor. Now, if I say 9 divided by 3 is 3, and remainder is, what is the remainder of the division? 9 is 0. Perfect. What do I really say? I'm saying to you that 3 is a of 9. Say it again. Close. But it's the other way around because 3 cannot be a multiple of 9, right? Yes, I can say that 9 is divisible by 3, but here I'm saying 3 is a of 9. What is the word I'm missing? It's a key word. Thank you very much. So now, coming back to our problem that we just discussed, what can I say about 3x squared minus x minus 3? Is a, yes, factor of 6x cubed plus 13x squared minus 11x minus 15. Why? Why can we conclude that this is a factor of that?
That's 0.
Because the remainder is 0. For the same reason why 3 is a factor of 9, because 9 divided by 3 has remainder 0. This is called the factor theorem. This is factor theorem. If the remainder of a division is 0, then what I divided by is a factor of the top. Let's look at the synthetic division now.
So if
Yes? Yes. Yes.
so if you determine that you can do long division,
Yes?
will there ever be a time where you do the long division and it doesn't come out to 0?
Yes. More often than not.
Oh.
Yes. Chris, go ahead.
Where do we get that 2x squared again? Underneath the 13x squared.
This one?
Right there.
Okay. 2x times 3x squared is 6x cubed. Change the sign. 2x times negative x is negative 2x squared. Change the sign. 2x times negative 3 is negative 6x. Change the sign.
Alright, sure.
So when I go back, I saw that just 1 second. When I go back, I have to go back to all 3 terms. Yes, please.
So, if we use synthetic division, and well, will it be a problem where we can either choose between the linear, the long division, and the synthetic division?
You can only in specific situations. If the denominator is x plus 5 or x minus 3, you have 2 options. If the denominator is anything else, well, you only have 1 option. If the denominator is a monomial, you just separate the fraction. Joseph?
My only question was, I'm making an assumption, it might not be right. We're having two positive signs. And when you multiply 2x minus 3x, it's minus 2x squared, correct? Why are we having plus? Are we using the minus sign outside to affect the one inside?
So you're asking why 2x times negative x is the result is positive 2x squared? Okay.
Are we multiplying throughout by negative?
No. So let me explain. When I divide 2923 by 15, I say 15 goes into 29 once. 1 times 15 is 15, and I get 44? No. I have to subtract. Although 1 times 15 is a positive number, I have to change its sign before I write it under that. For the same reason, 2x times 3x squared is 6x cubed, and I have to subtract. For the same reason, y times 15 is not negative 15, but I have to subtract. So I have to write negative 15, although 1 times 15 is not negative 15. For the same reason, I have to change all signs because I have to subtract.
You change all the time.
All the time when I write underneath, all the time. Because I have to subtract, like I do with 15, although 1 times 15 is not negative 15. It's the same procedure. It looks differently because it has x in it, but it's the same algorithm. So this time this is positive, but I have to subtract. This time this is negative, and when I subtract the negative, it becomes positive. This time this is negative, but when I subtract the negative, it becomes positive. That's the requirement. Otherwise, you can proceed. Like here. Do I write 15 and I add and I get 44? No, I have to write 14. Is that better? Okay. Okay, well, we have to talk about it some more.
So you basically took 15 out, so you subtract the 15.
Exactly,
and then what's
although 1
left
times
over is-
15 is not negative 15.
Is that one whole number? Or is that two separate?
No, this is 2923 divided by 15.
But that's why you take the 15 out, because you already accounted for that 15 by putting it
Exactly,
on top.
and that's why I
you
have to subtract. Yeah, for the same reason here.
That's
This,
like when you learned division as a kid.
yeah,
That's how you did it.
Now, my point I'm making here is the minus sign is affecting the whole 3x, 6x squared minus 2x plus 6x. That's
Okay, so you're
expecting.
okay.
So-
So your question. So let me ask this. So would you like us to show that this is the correct answer?
No, I don't want us to show that.
No, but we can. We
So
can.
is that our final answer for this problem, 2x plus 5?
Yes, because the remainder is 0.
And this is just long division.
Yes.
Okay.
So what was it? What is the question again? Joseph, go ahead. What is the question? What is the question? So you have doubts that whatever we did here may not give us the correct answer.
No, I have no doubt.
Because I would like to show why it is the correct answer. When you multiply this by this, you will get that.
I have no doubt.
Okay.
All I was thinking is
Yes?
maybe the way you're explaining it is what it's kind of confusing me right now.
Okay. Well, we can, after class, we can sit down and look at more problems. I'll be more than happy to help you. Okay, so let's look at the synthetic division now. And I'm going to pick a problem. You feel free to do that if you want. Let's say problem 20. Oh, he's here. So 5x squared minus 12x minus 8 divided by x plus 3. Okay, so now I'm going to ask the following question. Both 20,
No, the first number is 5.
5. 5x squared minus 12x minus 8 divided by x plus 3. Ready? 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 Okay, so are these two polynomials in descending order?
Yeah.
Okay, can I use synthetic division?
Oh.
Yes, my question is, can I?
Yeah.
Can I use long division?
Yeah.
Perfect. Good. So here's the algorithm for synthetic division. In this little box, we are going to put what is called A. So this, compare it to x minus A. By comparison, you will be able to tell me what A is. We've done this with a circle. We've done this with other things. Careful. If A is 3, then I will not get x plus 3. Correct. Indeed. Good. Now the next step is to write all the coefficients. They're in descending order. All the coefficients, including the missing ones. What is the degree of the top? 2. Is there a term with degree 2? Of course. Is there a term with degree 1?
Mhm.
Is there a term with degree 0? Perfect. So no missing term. All coefficients must be there, and if the term is missing, then we have to write 0. The algorithm for synthetic division requires us to copy the leading coefficient. So we just copy the leading coefficient. And here's the next step. Negative 3 times 5 is how much? I have to write exactly, here we are not lying. We lied here, if you know what I mean already. So negative 3 times 5 is negative 15. Perform the operations I see, and I get negative 27.
Oh, okay.
Negative 3 times negative 27 is positive what? 81.
Okay, wait. I see what happened here. Alright, so this times this equals
It's positive 81, correct. So 81 minus 8 is positive 73.
This is a mess.
Which part? Which part is confusing? Negative 3 times 5 is negative 15. When I add these, I get negative 27. 2 and 5 is 7. 1 and 1 is 2. Is negative 12 minus 15 negative 27? Negative 3 times negative 27 is 81. When I add these two, I get 73. I always box in the last number. What was the degree of the top? What is the degree of the bottom? Correct. When we divide degree 2 by degree 1, what is the result? The degree of the result. No, that's not possible. When I divide degree 2 by degree 1, I cannot get degree 2. When I divide degree 5 by degree 1, what do I get? Correct. When I divide degree 2 by degree 1, I get? Perfect. Which means that this is the coefficient of which term? Very good. X, degree 1. And this is the free term. So can anyone dictate the final answer? Very good. Awesome. What is the sign of this of 73? I have to write plus. What do I have at the top? If this is 0, I will put 0, but the remainder is not 0. 73 over, that's it. So this is how we perform the synthetic division.
So why is 73 the remainder? Explain that again.
Because degree 2 divided by degree 1 is degree 1. This belongs to degree 1, this belongs to degree 0, so this must be extra. The last one is always boxed in, and the last one is always the remainder, whatever that is. It could be 0 or it could be anything else.
I mean, I get it, but this is ridiculous.
Very good.
A little extra.
Any questions? Sure.
Wait, move back down. I can't see.
Okay, one more, and then we continue with something else. So let's say x to the 5th plus 4x to the 4th. It's 4th. Minus 3x squared plus 2x plus 3. Everything divided by x minus 3. Ready? Are they both in descending order? What is the degree of the top? Is there any missing term?
Yes.
Perfect. So please dictate the box first. Very good. Dictate the coefficients. Yes? Yes. Careful. Careful. 0. Next one. Next one. And next one. Very good. We bring down the first coefficient always. The missing term, cube. So please dictate. 3 times 1 is? Very good. 4 plus 3 is? 3 times 7 is? 21 plus 0 is? It's all the same thing. It's the same procedure. 3 times 1 is 3. 3 times 7 is 21. 0 plus 21 is 21. 3 times 21 is? Very good. 63 minus 3 is? 3 times 60? 180 plus 2? 182. And 3 times 182? So it's 6, 4, and 1. 4. So what is the remainder?
5.
Yes, thank you, thank you, thank you. So what is the remainder? 5? 549. So what is the degree of the quotient? So I know where to start. The degree of the quotient will be?
4.
Yes. So this is the coefficient of?
1.
Which is?
4. Wait,
One
what?
what?
1x.
Not 1x. 1x to the 4th.
Yeah.
Okay, perfect. Plus.
7x
Yes?
the cubed.
Awesome. Plus. Plus. Excellent. I knew you would be a piece of cake.
I mean, I still don't understand the whole, the way you calculate it.
You mean 3 times 1 is 3? And 4 plus 3 is 7?
Yeah, but I couldn't watch it because I'm trying to keep up.
Okay, so
So-
3 times 1 is 3, 4 plus 3 is 7, 3 times 7 is 21, 0 plus 21 is 21, 3 times 21 is 63, 63 minus 3 is 60, 3 times 60 is 180, 180 plus 2 is 182, this times this is this, and it's done.
Did you record that?
Can you do
Yes.
that one? Can you do that one more time? Just go through it.
3 times 1 is 3, I add is 7, 3 times 7 is 21, I add is 21, 3 times 21 is 63, I add and I get 60, 3 times 60 is this, I get 182, 3 times this is this,
Okay.
and I add and I get 549. Degree 5 divided by degree 1, this is the answer, it's not an equation. It's not an equation. Hold on, hold on, hold on, hold on, hold on, hold on, please. So this belongs to x to the 4th, x to the 3rd, x squared, x, no x, and 549 over x minus 3. Is that okay? Perfect. Yes?
How do you get x to the 4?
When I divide degree 5 by degree 1, what degree do I get? What degree do I get? Good. So then this belongs to the 4th, this belongs to the 3rd, 2nd, 1st, and no x. So that this is the remainder. Yes? Go ahead. Any questions? Yes, please.
So, is the test still Wednesday or is it?
No,
Nah.
no, no. So let's continue with 3.5, rational functions. Okay, rational functions are of 3 types. So type 1, like f of x equals x plus 1 divided by x minus 3.
What is that? I mean,
Type 1, type
Oh.
2, like f of x equals x plus 1 divided by x squared minus 1. And type 3, like f of x equals x squared minus 2x plus 1 over x minus 3. So rational functions are nothing else but ratios of 2 polynomials. So a rational function is a ratio of 2 polynomials. Okay. I divide these rational functions in 3 different categories. The book does not present them like that. The book just shows different things and does not separate them into 3 categories. These are the only 3 categories that we can look at in this class. There are only 3 categories of rational functions? No. There is more than that. But in this class, we cannot go beyond this. So this is type 1, type 2, and type 3. Let's analyze type 1. What do you think is the characteristic of type 1? Obviously, they must be different somehow. So what happens here? What is the difference? Say it again? No, it's a polynomial over polynomial. That's nothing. It has nothing to do with the plus and minus. What is the degree of the top? What is the degree of the bottom? Good. So the type 1 is when both top and bottom have the same degree. Both polynomials have the same degree. They can be degree 2 over degree 2, degree 3 over degree 3, degree 1 over degree 1. As long as they have the same degree, top and bottom, it's type 1. Now, in view of what we just discussed, what do you think type 2 is?
The denominator.
Is
Larger degree.
higher degree. Very good. That's all it is. Denominator has higher degree. Perfect. That's type 2. Awesome. Now, what do you think about type 3? Yes, but here we are limited exactly by 1 higher. So for type 3, degree at the top is n plus 1, and degree at the bottom is n. So if the bottom has degree 2, what is the degree of the top?
Right.
And
If the denominator has degree 5, what will be the degree of the top? Yes. We cannot go beyond that, meaning we cannot have in this class a degree that is 5 and a degree that is 2 here. It's too complicated. We need calculus for that. Okay, so now let's start with the first category, or the type 1, x plus 1 over x minus 3. So f of x, x plus 1 over x minus 3. We will do a lot of what we just did in polynomials. But let's go through the list of requirements here. Number 1, we have to identify the type. So we will have to say, okay, is it type 1, is it type 2, or is it type 3? What am I facing here? What am I expecting? Yes, in this case, we haven't discussed anything else. This is type 1, of course. In number 2, we have to determine what? That we always determine. Always. For yes, it's rational, type 1. Correct. So what is the first thing that we determine in all cases? Awesome, thank you. In step number 3, X-intercepts. And possibly their what? Yes. It starts with M.
multiplicity.
Exactly. I don't know. Multiplicities. Number 4. Something we have never seen, we have never discussed. Vertical asymptotes and behavior of the function near those are the vertical asymptotes. This we have not discussed yet. Vertical asymptotes and behavior near the vertical asymptotes. Number 5, y-intercept. Number 6, and behavior and horizontal or never end or slant asymptote.
What does that say after and?
Horizontal or slant. It cannot be both. 7, max min. 8, range, if we need to. Any questions so far? Okay, let's talk about this. Vertical asymptotes and the behavior near the vertical asymptotes. And let's talk about the end behavior of this function or any rational function. Now, let's take a look at a situation in which a function does not exist, let's say at x equals 4. At x equals 4, the function does not exist. It's not defined. I cannot plug in 4. And if it's a rational function, here's what is going to happen if it's a rational function. The function can do this or this. There are basically 4 possibilities. The function can approach x equals 4, going towards infinity, or going to negative infinity on both sides, or opposites. Only because the function is undefined here. It will never, ever cross this line. This is what we call a vertical asymptote of the function. When the function is undefined and the behavior near the vertical asymptote is either positive infinity on both sides or negative infinity on both sides or opposites. That would be a vertical asymptote. And we'll discuss it in a minute for the function we have. Now let's talk about the end behavior or horizontal asymptote. A function like type 1, like what was the function x plus 1 over x minus 3? Or let me change it. I'm going to change it just to discuss it, just to discuss the horizontal asymptote. What happens here is when the rational function has same degree over same degree, you will have a horizontal asymptote, which means at infinities, the function will approach a number. It will not do this, like polynomials. Polynomials don't approach a number at infinities, right? They do this, or this, or this, or this. But the rational function type 1 will approach a number when x approaches negative infinity or positive infinity. And that number is determined for type 1 as the leading coefficient of the numerator. Of course, you have to expect that this is in descending order, right? So the leading coefficient over the leading coefficient. So for this function that I just made up, what is the leading coefficient for the top? What is the leading coefficient of the bottom? So what is 2 over 1? So the end behavior and the horizontal asymptote will be 2. Y equals 2 for this function. Okay? So now let's go through all the steps. We had just a little bit of understanding of what that means, but let's go back to our function. So we have f of x, which is x plus 1 over x minus 3. In number 1, we identified the fact that it was a rational function type 1. Oops. In number 2, we need to identify the domain. Without the domain, we can't proceed. So, can anyone give us a domain of this function? Say it again. Remember rational equations. We solved rational equations and we said, except, all your numbers except, what could be the problem? That's why I begged you to redo your test. Every weekend, redo your first test with solutions. You will forget.
Oh, except for 3.
Exactly. Why except 3? Exactly. It cannot be 0 in the denominator. So therefore, the domain of this function is perfect. Yes, perfect. Union. Of course. Perfect. Number 3. Since this function is undefined at 3, what do you expect x equals 3 to become? Yes. Since the function is undefined at x equals 3, what do you expect x equals 3 to become? A vertical asymptote. So this is the VA.
I thought that was number 4.
Oh, the order is not important. Sorry about that. I can change this to 4 if that is confusing. That's fine. So then we have to insert number 3. What is number 3? The x-intercept. Okay, how do I determine the x-intercept? Very good, awesome. So here is x plus 1 over x minus 3 equals, and this should ring a bell because we've done this so many times. So cross multiply, awesome. So please cross multiply and tell me what you get. X plus 1, awesome, equals? Perfect, which means x equals? -1. So what is that ordered pair? That is the x-intercept? Awesome, thank you very much. So in number 4, we already identified the fact that since the function is rational and it's not defined at 3, x equals 3 must be a vertical asymptote. Now, we want to determine what happens left and right of the vertical asymptote because there are 4 options. 1, 2, 3, 4. Okay. So, yes? Say it again.
When you just go to the last step, 0, what do we do 0 and 1? X plus 1 over x plus 3 plus 0 over 1.
So we said y equal to 0. The function is x plus 1 over x minus 3. I set it equal to 0. And I wanted everyone to remember that this is a proportion, and I'm allowed to write 0 over 1 anytime I want. If it serves any purpose, any good purpose, I'm allowed to write 0 over 1. Good. So x equals 3. So we know now that at 3, the function will have a vertical asymptote, but I don't know the sign of the left and right. So I'm going to plug in this function. I'm going to plug in a number close to 3 from the left, like 2.9, and the number close to 3 from the right, like 3.1. And I just need to find the sign. So let's plug in 2.9 at the top. What is the sign? Good. Let's plug in 2.9 at the bottom, and what is the sign? How much is positive over negative? When we divide positive by negative, we get? Very good. So then on this side, the function will go to negative infinity. Let's plug in 3.1. The top is? The bottom is? It's 3.1, right? 3.1 plus 1, 3.1 minus 3. So it's positive. So how much is positive over positive? So then on the right-hand side, the behavior will be positive infinity. So on your left, the function will go to negative infinity. On your right, the function will go to? That's it. It will look like this, near x equals 3. Good. What did I say was number 5? Number 5 was the y-intercept. Very good.
What is that? What did we just do? That was the vertical.
The behavior left and right. So we already established that x equals 3 is the vertical asymptote. But I also need to determine the behavior left and right.
So we just did number 6, the in behavior and horizontal.
No, we did vertical asymptotes and behavior near the vertical asymptotes. We still did number 4 and nothing else.
Okay.
So we're now in number 5. Is that better?
Mm-hmm.
Good. So the y-intercept. How do I determine the y-intercept for any function? Very good. So let's plug in 0. What do we get? Yes, negative 1/3. So the ordered pair is this. Now number 6. What did I say number 6 was? And behavior. Very good. Since this is type 1, the end behavior and the horizontal asymptote is y equals the leading coefficient of the top, 1. The leading coefficient of the bottom, 1. So 1 over 1 is 1. Very good. And 7, max min with the calculator if needed, and the range is 8. So now let's create a table. Any questions? Any questions? Jesse, go ahead.
No, I was asking him what that said.
Horizontal asymptote is y equals 1. Yes, please.
Why is there a horizontal asymptote?
Okay. I can show you algebraically why, and I can do both. Or just remember, if it's type 1, the horizontal asymptote is obtained by the leading coefficient over the leading coefficient. So if it is type 1, only for type 1. Okay, so now let's summarize all our information in this table that we used for polynomials. The same thing. Domain, negative infinity to infinity. 0 has to be in the table. 3 has to be in the table, and it's going to be undefined. We know that the function does not exist at x equals 3. I know that there is a x-intercept at negative 1 comma 0, negative 1 comma 0. I know that we have 0 comma negative 1/3. I know that x equals 3 is a VA. I know that the end behavior and the horizontal asymptote is y equals 1. And I determined the behavior of the function left and right. What did we determine is on the left? Negative infinity. And what did we determine we found on the right? That's it. summarized all the information like we did with polynomials. Let's follow this through. So it's coming from approaching 1, coming down to cross the x-axis, then it's crossing the y-axis, and then it drops to negative infinity on your left-hand side of the asymptote. On the other side, it's coming from positive infinity approaching 1. Let's do this one more time. From approaching 0, crossing the x-axis, crossing the y-axis, going towards negative infinity. On the other side of the asymptote, coming from positive infinity and approaching 1. That's what we see. So let's do this together. Let's graph it. When we graph functions with asymptotes, we must start by graphing the asymptotes. That's a requirement. So I will graph